We create GeoJSON files because they are easy to import and process in Deviceflo, where they are a visual aid for planning and maintaining devices. This clip shows how we can convert PDF files into GeoJSON files in a few minutes and use them in Deviceflo or other digital planning solutions. We have created a new project in QGIS and are zooming in on the area of the building for which we have a floor plan. We will start by adding a new layer and loading the PDF file, which we will then manually place in the correct position. Before we can start, we need to change the transparency of the PDF document so that it can be positioned in the right location. Also, you will need to install the freehand raster georeferencing toolbar as a plugin. The toolbar will then be visible at the top, and we used it already to load the PDF file. Using the rotate, move and scale functions, we manipulate the PDF until it is in the right position. This is somewhat tedious work and will take some time at first. The solution proposed here should allow you to process a file in 20 to 30 minutes, depending on the application. In this case, it is an intelligent office application, which means that each workspace has to be added, which takes some extra time. QGIS is open source software that can be downloaded and installed for free. It has a large support community and many plugins are available. The accuracy of the positioning depends on the project requirements. After a few iterations, we finish this part of the conversion process. Once this is done, we create a new layer, a shapefile layer, to draw the floor plan on top of the PDF document. We select polygon as the vector type, and when creating the field list it is important that we first remove the integer ID field from the list and then add it back as an integer value. This gives us more flexibility in defining the format of the metadata that we assign to the objects on the map. We also add the name field to the field list and we are ready to start drawing. From now on it is simple. We need to draw the floor plan and add the correct naming. First we enable toggle editing, then we switch to feature drawing mode. The first step is to draw the outer walls of the floor plan, effectively fixing the canvas surface. Naming conventions for the objects on the maps should be a key project discipline. As Deviceflo adds this directly to the generated data stream as metadata, there should be an agreed convention for what an object is called on a map to make life easier for the data engineers when interacting with the project team. When we have finished drawing the canvas, and for every other object we draw, we end the drawing process with a right-click and then enter the metadata. We use identical values for the ID and name fields. This is the first layer of our floor plan, defining the external walls of the building. After adding the outer walls, we draw the common areas of the floor plan. This is the space inside the building that is not closed off by a door. In this open plan office, this is quite a large area. Again, accuracy can be improved by zooming in and drawing more precisely. As this is not an architect's plan, but a digital floor plan for planning and installing sensors, the accuracy we use here is good enough. After the internal walls, we continue to draw all the rooms in the building using the same methodology. This is how we create the floor plan, layer by layer, room by room. We now follow the same procedure for all the workstations in the office, adding them one at a time until we have a complete inventory of relevant points of interest. The final step is to export the file as a GeoJSON file so that it can be used by Deviceflo and other digital planning tools. It may be useful to add a date to the file name that is saved. If the office configuration changes, it is easy to go back to this QGIS project and update the GeoJSON file with the latest configuration. This removes a significant cost from the maintenance of smart office costs, where office workspaces tend to move around quite a lot. The result can be verified in a GeoJSON reader to check the correctness of the work and can be used in Deviceflo project planning and execution. As mentioned earlier, correct naming conventions for points of interest on the floor plan are critical, as they are automatically added to the data stream as part of the registration process that takes place in Deviceflo. Maintaining the floor plan, editing, labeling and moving objects on the map can also be done using the QGIS software. In Deviceflo, we can import the GeoJSON formats under the Customer Sites tab and make them available as a planning canvas for projects. As a next step, we can use the canvas to plan the rollout of the Smart Office project. We plan a device for every smart desk in the office that can be booked remotely, giving workers the insight on the availability of smart desks before planning their trip to the office. Deviceflo's tools support the hardware operations layer of these use cases by providing project management and installation tools throughout the IoT hardware lifecycle. What we show here in a web interface can also be done with Deviceflo's tablet version, planning and documenting the project during a site survey, keeping an overview at all times. There is a link to a demonstration of this tablet process in the comments below this video clip. Thank you for your attention. Please visit www.deviceflo.io for more information or contact your sales representative directly for further assistance.